good morning. I have marked your assignment yesterday, and I was very happy to see your effort and the great work you have done. Actually, I'm very pleased to see that you understand factoring, which is one of the most important topics in this year. I have two small comments. The first one is about this problem, 7a to the power of 4 minus 7b to the power of 4, and we want to factor this. So as we learned, we factored the common factor out, so 7 is out, and a to the power of 4 minus b to the power of 4, that's what's left inside. We are not done. 7, this is a perfect square, and this is a perfect square, and minus between them. So there is, we're going to use the process of difference of two squares, which is a squared minus b squared times a squared plus b squared. Most of you did up to this step. The thing that I want to tell you is we don't stop factoring until we factor completely. We cannot factor anymore. So this can be factored again, because this is a difference of two squares as well. So we can factor this as a minus b, a plus b. Then we cannot factor this because of the plus. So this is factored completely. So when you have a factoring question, don't stop until you cannot factor anymore. This is when the question ends, when the problem is completely done. Okay, so keep factoring as long as you can factor. Okay, this is the first thing. The second thing is we don't use AC method for every problem. It works for every problem. It can factor any problem, but it is not very efficient. It is not efficient when you can factor using another method. So, for example, I think the last example was a squared minus 16a plus 64, something like that. Okay. I don't use AC method unless I try everything else. So factor common factors, nothing. This is 3 terms, so we go to the right side of the chart. Is this a perfect square? Let's see. 1 is a perfect square, C is a perfect square. Square root of 1 times square root of 64 times 2 will give us 16. So yes, this is a perfect square. So we don't need to use AC method or any other method. We just open one bracket and we put a square here, square root of the first, sine of the middle, square root of the third. Okay, those were just two quick comments I want to tell you before we start today's lesson. So today we are going to talk about the method of completing the square. The first thing we need to know when we use the method of completing the square. Okay, all of us know by now that we have 3 forms of quadratic. The first one is standard, which is in the form of ax squared plus bx plus c, and factored, which is in the form of ax minus s, x minus r. And the third one was vertex, which is in the form of ax minus h squared plus k. Those are the 3 forms of quadratics, and each one of them benefit we have benefit from it. This one, we can tell that this is the y-intercept. We can tell that it opens up or down right away just looking at this. If A is positive, it opens up. If A is negative, it opens down. The value of C is the y-intercept. Here we can tell S and R are the zeros, are the x-intercepts. And also we can tell if it's open up or down. Here we can tell the coordinates of the vertex, which is H and K, and if it opens up or down based on the sign of A. And this helps us find the maximum and the minimum. So vertex form K is the value of the maximum or minimum. So like if we have here the thing like that, this is the coordinates H and K. K will be the maximum value of Y. If it opens the other direction, based on A, if A is positive, this is the minimum. So each one of those forms have its own benefits, okay? It is very important to know how to switch from one form to the other. We learned that if we have factor, then we want to go to standard, we use the FOIL method. And if we want to go from standard to factor, we use the factoring, the chart. Now we want to learn how to go from standard to vertex, and this is the method that we use it today, which is completing the square. So completing the square is the method we use to switch from standard form to vertex form. Okay, this is why we use, or when we use completing the square, to switch from standard to vertex form. Okay, now what is that method? What is the method of completing the square? You know, if we have this quadratic in standard form, 4x squared minus 20x plus 25, this is a perfect square, right? And we know that we can factor this to be 2x sine of the middle, oh sorry, this is 25, and the square of that is 5, okay? And if you look at this, this became in the form of let me give you another example, maybe easier. X squared plus minus 4x plus 4. This is a perfect square because A is a perfect square, C is a perfect square. Square root of A times square root of C times 2 equal the middle term. So this is x minus 2 squared. If you look at this, you can see that this is in the form of ax squared plus bx plus c, which is a standard form. And this somehow looks like ax minus h squared plus k, where k is 0 and h is 2. So right away I can tell that the vertex is at 2 and 0, and it opens up, so the graph probably looks like this, and it will have a y-intercept here at 4, and we can sketch the graph. Alright, so when it is a perfect square, it is easy to, by factoring the perfect square, you will get the quadratic in vertex form. But unfortunately, not every quadratic is a perfect square to switch, that allow us to switch from vertex form to, from standard form to vertex form right away. So let us say we have a quadratic that looks like this. Okay, y equal x squared plus fx plus 5. Y quadratic in standard form, y-intercept is 5, and it opens up because a is 1. But is this a perfect square? Unfortunately, it is not. 1 is a perfect square, c is not, so it is not a perfect square. So we are going to use the process of completing the square to somehow manipulate this and make it in vertex form, and by using the process we're going to make the quadratic that's not a perfect square a perfect square. So we have to complete the missing things to make this a perfect square. That's why we call it completing the square. It's not a perfect square, and we are going to make it a perfect square by completing it. Okay? So what is the process of completing the square? The first thing we do is we group the first and second term. That's when a is 1. Tomorrow I'm going to do when a is any other number. Okay? So we group the first and second term. Then we get the number in front of x, we get b. So group first and second terms. And we put brackets around them. The second thing, get b, the number in front of x, number in front of x. Then we divide it by 2, then we square it. So for here, 8 divided by 2 is 4. Then we square the 4, we're going to have 16. Okay? Now, I am going to use this number I get in step 2 to make this a perfect square. So I will write this as y equal x squared plus 8x plus 16. Now this is a perfect square. But there is a problem. I cannot, if I add the 16, I'm not maintaining the same equation. I added a number. So how I overcome this? I subtract the same number between the brackets. Okay? Now, adding 16 and subtracting 16, that means I added 0. So I didn't change anything. I just played the game to make 16 in here. Okay? Now, the next step, remove the negative value from the bracket. So we are going to rewrite this like that. Y equal x squared plus 8x plus 16. And I'm going to take this out, and there is nothing in here multiplied with the whatever inside, so we take it out as it is, negative 16 plus 5. Then we do the last step. What is the last step? Now this is a perfect square, so we factor the perfect square, factor, and combine like terms. So we're going to factor this. Y will be x sine of the middle and square root of the third, and we put a square here and we combine those, so we are going to have negative 11. Look what happened. This is in the form of a x minus h squared plus k. So we were able to switch from standard form to vertex form using those 5 steps. Okay? I will continue in the second video. I will give you more examples. Okay? All right. See you.